have in the architecture industry, and then learn how to sort of meld these together with our current process to bring about a better result for what we intend to do, which is design buildings. So virtual reality is the next step in architecture. It's the next step because virtual reality brings us to a place, it transports us to a location that we currently either are not at, a location, for example, Italy, Rome, Venice. It brings us to a creation in the mind of a game designer, in the mind of an experience designer, or it could be a temporal-based location. So we can go in the future, we can go in the past. In fact, sometimes when you're designing a building and you're going to go access the building before it's designed, there's a way of going into the future to change something that you can fix today. So as I said, VR is important because it transports us. It teleports us. And I lost connection with my screen. There we go. Let's see if it goes. Yeah. So it transports us to a place that we currently either are not at, for example, the Colosseum in Rome or the Venetian canals in Italy. And the main point of transporting us to this space is so we can feel the space, right? You hear architects use that word feel all the time. Feel, feel. The space feels too big, it feels too small. And essentially, what are they saying there? They're saying that they're trying to explain the scale of the space to you when they say the space feels a certain way. And it's not the scale of the space that's as important. It's the scale of yourself in relationship to the overall space. So this access to scale is, in the world of architecture, is new data. Because previous to this access of scale, we don't have this data. So another place the VR experience can transport you to is architecture. A building, not necessarily a game. A building that doesn't necessarily exist yet. We can go inside, or we can go outside. I'm waiting for the projector to, I don't know why that's happening, I'm sorry guys. Inside the space, or outside the space as well. And again, what we're trying to access here is the scale. Scale is one of the single most important determining factors in architecture, the scale. And unfortunately, currently the way we do things, we can't access that scale until the project is complete, until it's built, and then it's too late. Not necessarily too late, but it's costly too late. So that scale, that feeling, that information is very important, it's very vital to architecture. We can jump into, these are what are called VR stereoscopic panoramic renderings. So rather than just looking at your rendering, we can go in the rendering now. We can stand on the street, we can look at the building, we can understand the spatial qualities. So speaking of scale, let's talk about a famous building, St. Peter's Basilica in Rome. It's one of the most famous buildings in the world. This building was designed on purpose to make you lose your sense of scale when you enter it, because it represents the house of God for the Catholic religion. How does it do that? Well, here's an example of the intersection of the nave and the narthex in the Vatican. How high do you think those, let me use my laser pointer here. How high do you think those letters are up there? How tall? 2.5 feet? 3 feet maybe? It's hard to tell because we're really far away from this. We can get a little closer. Those letters are actually 6 feet tall. Now you don't know that because you're so far away from them, but that's the whole point. The whole point is for you to lose your sense of scale, to bring you into this awesome place, and for you to be in awe of that place. Another way you lose scale in this building is the dimension from the floor to the ceiling, the interior dimension of the dome. This is 393 feet. Guess what can fit in there? Including the pedestal. This is 303 feet. So this is starting to tell you about how important scale is in architecture, and how important is to a great design, for the feeling of a great design. And VR allows us to access that scale. It allows us to enter the space. It allows us to see how it works, to see how it interacts with the public. Does it create a community? What's the view corridor? What's the interesting element? What am I going to see? What am I going to feel? Is more important, because we can't answer that question in any other way right now until the building is built. So talking about the feel of the space, the scale of the space, we're talking about data. We're talking about data in architecture, right? So let's take a look at data in architecture. Let's take a historical look back at it. Let's take a really far step back to 1502 and talk about Da Vinci. So in 1502, Da Vinci was looking to get a commission from the Borgia family. And so what he did was, he walked the city of Imola. He drew a map by hand. Now maps were not very evident back in the 1500s. They didn't exist. So he walked the entire city and he created a map. Why did he do that? Why is that important? This is data. This is data for the Borgia family. They now know their city. They understand the edges. They understand how and where they can fortify. They can militarize now. And then let's just take a look at how accurate he was. This is overlaid Google Earth. This is 1502. This is current. Very, very accurate. This data, this information, was very valuable to the Borgia family, so he got the commission. So let's take a look at how the data was purveyed. Hand-drawn on paper. That's it. Very simple. Hand-drawn on paper. So let's take a step in the future a little bit more. Let's take a step up. In 1906, Frank Lloyd Wright, one of the most famous architects in the United States, in the world. And the Roby House. This is the Roby House. This is not. So we'll take a look at this one. This I just want to show an example of a hand-drawn perspective. So wonderful, beautiful, celebrated design. We studied this in school. How is the information purveyed? Hand-drawn on paper. Same amount of information. It's really hard for you to tell me how it feels in that room right there, how it feels in that room, because we're not there. And the data is two-dimensional, it's flat, and it's hand-drawn on paper. So that means we've gone, let's take a different view, a 3D view, still hand-drawn on paper. So you're starting to get an understanding of some of the massing and things like that, but I don't know how this feels yet. I can't understand and ascertain the scale. So we've gone from 1502 to 1906, we've gone 404 years and not progressed our data. So we're still doing hand-drawn and we're still doing hand-drawn. Same data. Now let's go to 1975 to 1980s. CAD was invented. Computer-aided drafting, or CADD, computer-aided design and drafting. This is essentially taking something that we used to do by hand and computerizing it. Same thing we did. So it's the same data, it's just in a more efficient way. So you can imagine an architect back in the day had to design, they had sheets of paper, and so they have to, this is their sheet of paper. Before I draw, if I'm the architect, I'm drawing by hand. I have to understand how big each of my drawings are, and if there are notes for each of those drawings, everything's done by hand, including the note-taking. And I have to lay that out, and then lay the drawing next to it, and this is for one sheet. And then you have to do 10 or 20 or 30 sheets. It's a mind-blowing, too much work. So CAD really helped us with that. It made us more efficient, but we're still drawing with lines. Lines are represented by color, and the color represents line weight, but it's still drafting. It's still drawing. It's more efficient, it's better, but it's the same data that we've been working with. It's just been digitalized now. So you can see still the same line work, still the same drawings, still the same elements. We're looking at them the same way. We're zooming in. We're doing things a little more efficiently. Here's a more representative of today's version of a CAD site plan, for example, instead of looking at the Roby House. Why don't you guys tell me what it feels like in that space right there? Well, you probably can't because we're not zoomed in enough. Let's zoom in. Tell me now. There's no way. There's not enough data to tell me how that space feels. So we've gone from 1906 to 1975, another 70 years, and we've made one little step, which is we've made things more efficient. That's all. We haven't added anything revolutionary. So let's get into the 80s and 90s. We have 3D Maxes invented. Now we have the ability to render. We have the ability to show off the space rather than just lines. So we can access style, we can access look, and we're slowly getting to the indication of what the space feels like. Because we're understanding more about light qualities and shadow and material. But are we truly accessing the space? No. Are we understanding the scale? No. Because we're not in it. We're still looking at it. But we've made another step, a small progress, but not a big leap. And we've done it again in 15 years. Let's take another step in the future. Let's come to current. 2000. BIM was invented, represented by Revit, in 2000. And it's used up to the current. So BIM, unlike CAD, computer-aided drafting, BIM is building information modeling. So now what we do is we build a model similar to the way you actually build the project. You build it in 3 dimensions, and then you cut it apart to look at it in different ways. Or you put a camera inside so you can look in the room. But this is a 3-dimensional model. It's not a 2-dimensional in any way possible. Typically, everything is built in 3D, so we can access the spaces, we can get a feeling for it, but we're still not in it. We're looking at it on a screen, or we're looking at it on a piece of paper. That's frustrating because we have all the data. Now we have the data. We have just recently gotten the data to go 3D. So here's the Roby house, and here's how we look in CAD, and here's how you have to draw it in CAD. You have to draw it flat, and you draw that elevation flat, and then each level flat. But in Revit, in BIM, this is how we model it. So you can see it's a 3D representation, and we can get all these drawings out of it. But we have the model. The model is there. The data is there. So we've gone another 12 years or so, and now we have the content. We're not just working with lines anymore. We're working with 2D and 3D parametric data that is not based on line work, it's based on objects. And objects have dimension. So let's work our way up to current, 2016, virtual reality. 2016 virtual reality hits the consumer market, kind of true. Not fully true, because the first VR we ever saw, well, I wasn't alive, and I'm sure a lot of you weren't, but it was in 1935, the Viewmaster. Now, this is analog VR, but it's still VR. It's not digital, but this Viewmaster put to your eyes with one of these discs would transport you to whatever that slide was showing. Again, analog, not digital, but our first look at VR. And now we have the 2 major leaders in VR. PS I don't have up there because it's more for gaming, so these are computer-based VR. We have the Oculus Rift and we have the HTC Vive. This is the sort of equipment we're using nowadays to access VR, and this is the sort of equipment that everyone is having access to now to use VR and to access this data, which is very important because this data, again, sort of talks about everything, and everything with architecture in terms of accessing that data. You need this equipment, you need the tech, you need everything to get involved. So VR in 2016, what can we do with this? Let's talk about it a little bit. So 2000 to 2016, there was about 10 years because BIM was not sort of digested by the industry until about 2006. It was invented, purchased in 2001 by Revit and Autodesk. So here we have a project. This is the Burbank Town Center. This is a project that my firm is working on in Burbank, California. This project represents about 1,200 living units, about 100,000 square feet of retail. The city of Burbank is very focused on this project, and more importantly, this plaza space here. This plaza space is going to be really utilized by the community, movies, markets, things like this, multi-use space for the community. So they're very focused on this space. They wanted to understand how that space looks. So here's a common way we're going to give someone an understanding of that space. Here's a rendering. Now this rendering, as you guys know, is very controlled. I control, the designer controls, the project manager, whoever controls the renderer, the view, the angle, the cropping, the photoshopping, but it gives you an idea of what that space is. Again, only 2D. We can't really tell what that space feels like. And the main concern was that the city had a concern with these tall structures. This is a residential structure there. This is a 250-key hotel. So they had a concern that standing in here, you may have a canyon effect. There may be these really big walls going up on either side, and there may be a problem with sort of feeling that space. So we went to Burbank and put the mayor and the city council in VR. And I took the mayor and I said, you know what? Rather than talk about that space, let's go in that space. So this is a video of what happened. We're in the space. There's the avatar. He's in that main retail plaza, and I had the mayor put on the goggles, put them on, look around, take a look at what you see, and then do me a favor and take a look up. And do you see a canyon effect? Is there a canyon effect? And when he did look up here, there clearly isn't. It's all blue sky. So he was able to see for himself in first person that there was no canyon effect. So he was able to solve that assuage that concern of this canyon effect. So we got the feel. He accessed the feeling of the space by going into it, and he understood the scale immediately. So let's take another example here. One Paseo, this is a project we have in San Diego, California. Very large project. I believe we're 600 units and 50,000 square feet of retail, 200,000 square feet of office space. And this project, again, very important for the community and, of course, the developer. And so we had a meeting with the client, and we put that in VR, and we had them look at all these different elements, and he was inside one of the units, and he was looking out one of the windows, and he noticed one of the mullions was right in his eye line. It was just right in front of his eyes. And he asked us if we could move the mullion down. And we did. We did right there, and it changed live in VR. What I'm trying to explain to you is workflow. And what I'm calling this is the wow to workflow effect. Because VR wows you, right? And you guys are going to put on goggles out there in the next, over the next couple of days or today, and you're going to be wowed by all the cool stuff you see. But the data, the way we digest the data, if we can get over that wow and go right to work, it's more valuable. Because the data is there, it's easily digestible. We can go from wow to workflow and get things done. And that's an example of what that developer did. This is another project we have called Beacon on Hill. This is in Los Angeles. It's a high-rise 35-story tower. And of course, with high-rises, you guys, views are huge. The client always wants to know, what am I going to see? And you can see where this is situated, this whole side of the building is facing toward the ocean. So this whole side of the building really wants views. And it really, more than wants views, we want to understand what those views are. So what am I talking about here? I'm talking about context. Well, nobody cares about context architecture currently, right? Because if you build a Revit model, you build it floating in space. You don't build it in the context. We design our buildings from the outside in. Nobody designs a building starting at the bathroom and then the main entry. We go from the outside in. But in VR, the building needs to be viewed from the inside out. It's a complete reversal. Because if I put you in VR into your unit, you're going to want to know immediately, what is my view out the window? What am I going to see every day when I wake up? So it's quite a reversal on what we're used to. So here's a couple of shots inside the model where you can see the context is gone. So now we're in the upper level club room of this model. What am I going to see? What am I going to see from my unit? What is my view when I'm washing dishes? What is my view when I'm cleaning my living room? Well, we can put you in there, and you can see that. So we're now in this unit, we're walking around. And it's this rendered, and this is not the highest level rendering we get. Remember, this is still workflow. This is still workflow. None of these elements are locked into place. I can edit and change any of these elements immediately on the fly while you're in VR. So we're not to the full level of VR. Here's the balcony, here's the view of the city. This is really important stuff in terms of marketing the building, understanding the building, where the view is going to be. How do I get from one space to another? What is the walk like from my unit to the elevator to the car? What is the walk like from, you hear the term in marketing all the time, the leasing tour walk. What is that like? Well, we can simulate that here actually in VR. So 2016 to 2020, what's next? Let's talk a little bit about that. The use of architecture, or the use of VR for architectural workflow is, I believe, one of the more important aspects of what's going to happen. But let's just talk generally real quick. Accessing a space through VR, being able to see that space through VR. Let's go beyond architecture for a second. Let's talk about marketing. So when you build a building, you have to have typically what's called model units, right? So you build a building and then you have 4 different types of units in the entire building, and you build these 4 to represent what all the units look like. So when you bring tours through, they can go look at the units. Those units aren't making you money, by the way. They're costing you a certain amount of money. You have to fit them out. You have to put materials, maybe they're 30 grand to fit out. You can take those are offline, not making you revenue. With VR, we can VR the whole experience and put those units back online. And we can make revenue. In fact, we can set up a VR room that is not even located in the same state as the project and have you access every view from the building. You can pre-sell the entire building before it's built. In fact, in China right now, you have to pre-sell your entire building before it's built. They're not allowing buildings that you can see through anymore. Because a lot of buildings that happened in China, big boom for construction, and then the building's brand new and nobody's had it. We're trying to avoid that in the future. So marketing, Matterport scanning, if you guys are familiar with this, or even point cloud scanning. Scanning a space and walking through it. So understanding the space through 3-dimensional photos and being able to actually walk through it. There's a lot of programs that work for this. This is an example of a Matterport scan. And I also work with programs where you can walk a point cloud, which is really cool. Very interesting too.
What does that mean?
So a point cloud is it's a 3-dimensional mesh of data that is taken from a scanner. So if I put a point cloud scanner in the middle of this room, it would scan and it would take little laser points from everything in the room, including the people, and it would create a mesh. Now the mesh isn't solid, it's made of points, but I can load that point cloud in, and if you sort of squint, you sort of see that it's 3D, and then you can overlay a mesh on top of that and make it fully solid. So you can actually walk point clouds, which is really interesting. It's a tech that we don't use too much in our field. A lot of real estate and a lot of things like that, they'll use point clouds to scan existing spaces before they lease them. Or for data and information that you don't want to build, you can scan it and then bring it into a 3D, and then you can build on top of it if you want to. Another interesting example is meetings, collaboration. How do we meet with our clients now? Well, we have GoTo. And I'll put you on the screen, you can look at me, we can look at each other, we can talk, but who cares? Because we're not critiquing and judging ourselves, we're judging the space. So why don't we meet in the model? Why don't we meet in the space we're judging? There's me, there's you, there's the other person. We're all avatars now. It's quite funny, actually, because you see the person as an avatar. And you say, hey, let's go walk. And you literally walk the model together. And while you're walking the model, you can annotate, you can take pictures, you can save things, send them out to the team, or you can link and make notes to the model, and then have a team member come back in and fix everything as you're going through with the client. So how we interact with our clients is also changing in a big way. So VR it's a game changer, and it's the next step in architecture, because this new data creates an incredible amount of value. The value that it creates is, right now, to access this value, we have to finish a project. And when you finish a project, if you finish a project and you have a problem with it, well, it costs a lot of money to move a wall that's already been built. It's very easy to move a wall when it's virtual and digital. So why are we not vetting our projects in VR before we build them? VR allows us to do that, allows us to create more precise buildings, and allows us to create better experiences, because I can talk about the feeling of a space all day long, but you guys don't know what that is. This feeling is personal, by the way. This is a personal feeling we have about space. By the way, I'm trained to understand space. Not many of you are. The general public isn't. I'm an architect. I went to school for this stuff. So I read plans and sections and drawings, and I understand them. You guys may not, though. And by the way, if a building gets really complex, it's even hard for an architect to understand it, if it's a very unique building. So VR, since it's a virtualization of reality, it levels the playing field. Because I don't have to explain reality to you guys. You guys see reality all day long. You can tell me what this room feels like without being an architect, because you're in it. So if I put you in the reality of another space, I don't need to explain to you how to read the space. You read it naturally because it's what you do all day. So we level the playing field now. We put everything on the same playing field, and now we can have everyone critique the elements of the room. You don't have to be trained, especially if it's your building that you're paying for. And the buildings that I work on usually cost above $100 million. Some of the multifamily projects we have are closing at $200 million construction costs. That's a big investment that you're going to put in there. Wouldn't you really want to know what the space feels like before you make that investment? I just lost that. And the answer is you would. You would want to go to that space. You want to feel secure that that space is right. And this is the way we do it. That's why VR is the next step for architecture, and I thank you guys very much for your time. I can open up for questions if anyone has questions now. I think we have a few minutes left. Yeah, any questions anybody have? I'll be exhibiting over in the main hall. My exhibition is mainly putting you guys into VR architecture. Sir?
What program are you using to make your build?
The program that we use for the data is Revit, so our normal BIM program. The program I use for VR is a program called Fuser. And it's a program that allows you to drop 3D content into its sort of open architecture world and then access it and walk through it. So SketchUp, Fuser, or SketchUp, Revit, Rhino, things like that. They all go into Fuser, and then Fuser you can walk through. So any of the videos you saw of the person, for example, in the plaza, that was Fuser. And it's built off an open world, open architecture platform like Grand Theft Auto, for example.
Is there a simple way to go from 2D drawings, 2D CAD drawings, to 3D VR space?
Not without making the 2D 3D. That's the only thing.
Is there a conversion? I mean, you can always pull a 2D drawing from a 3D drawing, right? So
yeah, if you, I don't know of something that can automatically, I mean, if you had a 3D drawing, or 2D drawing in CAD, you'd have to assign heights to each of the elements, right? It has to be 3D data. So a 2D,
which if we had,
convert it into CAD 3D or bring it in, yeah. You'd have to build it. You'd have to build it, so there's no real shortcut there. So the data has to be in 3 dimensions. So the 2D stuff is not going to work only as sort of a background, layout. So you need Revit or SketchUp or Maya or Rhino or some sort of modeling software to model to walk through it. Sir?
What would you say is the most compelling obstacle right now in terms of? I mean, it looks like Grand Theft Auto, but it could look more photoreal. Maybe
So,
that's not your goal. Like, I guess the question is, what's the most compelling thing? Is it ability to live edit, ability to transport to other sites, or are people wanting more out of the look?
for me, and for based on my experience, the ability to workflow, to have workflow. So the reason I've shown you what I've shown you here is not photoreal. I have examples of photoreal stuff, and we have access to photoreal. My team can put together photoreal. The only problem is when you go photoreal, you can't move anything. Everything has to stay exactly where it is. So photoreal is great for marketing. So the project is done, all the materials have been picked, then you have photoreal, because then it gives you that real example of what's going on, the light qualities of materials. The process of photoreal is expensive, and it takes a lot of time. And that's because if anyone knows about rendering, you have to bake in the properties. So you have to bake in the materials and the light maps to each object. And not only each object, every visible polygon. So that's why it takes a long time. And that work is typically not done by architects in my industry. They're done by video game artists, because that's how video games are made. So I have a couple models with me at my booth that are photoreal, would blow you away. But you can't do anything with them. You can't move a chair even. So there's a place for that though. It's just not in workflow. And for me, the value of VR is workflow, getting work done. So if you're the client, I put you in a room and we have an operator session where I sit at the computer and you're in VR and you're just pointing out, Matt, move this, change that, delete that, do this, until the room is exactly how you want it. And I'm changing it live. To me, there's a much more value there, much more value. Sir?
To make the plaza you showed, how many hours, I mean, let's say, do you use to get that ready for the VR, to show it in VR?
A VR experience, any sort of VR experience? If there are programs like Fuser where you can drag and drop a model. Just drag and drop. And Fuser will sort of computate that model within about under 1 minute, I would say. And I've dropped huge models of Fuser, 80 million polygons. Didn't think the computer would handle it. It did. Maybe about a minute, minute and a half, but you drag and drop, and then you can walk through. If you want to prep the model for VR, meaning you want to minimize the flickering, you want to minimize all the issues, your polygon load would have to be pretty low, and it could take you anywhere between 2 and 4 hours just to make sure the model's clean, and it's more about just cleaning and purging the file. So a simple walkthrough you can have ready anywhere between a half an hour and 3 hours on a simple walkthrough. But then again, if you have a huge, the entire campus, this campus, you want to walk through that, it's going to take a little more time because we have to prepare it.
I'm just curious, you alluded to the meetings with clients.
Yes.
Stakeholders. Do you find yourself coaching those folks, say this is the equipment you need, or you're finding, hey, people are embracing it?
They are part of the wow to workflow. So they are wowed by VR, and then they want to know, how do I get it? How can I get into it? So I have clients now that are probably really close, because I've just shown them demos maybe a week or two ago, really close to buying a whole VR setup. So they can meet with us, so we can have work happening in the model. But I feel that most clients, when they see the value of the workflow, and they see how much it costs to get into VR, it's a no-brainer. And they're just right in. And they'll purchase it, set up. I even offer, my firm offers a service like that, where we will set you up completely. We'll buy the computer, we'll do everything. And we'll train you, we'll show up at the office, and we'll make sure you're in VR. Because it takes there's a lot of knowledge about how to make everything work together, which we would rather you not go through the 6 months of trying to figure it out. Because it's sometimes, tech is. All you guys know what tech is. And sometimes it can be your friend, and sometimes it can't. But this I found is it's quite simple to use, and the value add to not only the industry, but the individual project is sort of exponentially greater. So, plus it's very cool. It's very cool to be in, one of the greatest joys of being an architect is to walk in a space that you've designed, and to see it manifest, and to realize that at one point in time you had drawn this on paper, and you had ideas about it, and to see if you get in that space, did it really work out? Did it work out? You can do that right away now, and we can change and edit and see if things have worked out right away. And so that's why it brings about a better project, a better result, and more efficient. Because at the end of the day, our clients want to know, am I going to make more money? The answer is yes, because we're going to have less meetings, we do less travel, we do less change orders. There's all this stuff that happens at the end of a project, we're going to have minimalization of that. So your request for information and all these kind of change orders that happen during construction, we can minimize all that stuff by just spending a little more time upfront with VR. Sir?
All right, so I've taken 100 people through the virtual experience already.
Great.
We sell the machines too.
Oh, excellent.
When you're all meeting, what are you using VR chat?
I use the program Fuser.
Fuser, so you're just inside of
Fuser is I should say, a fantastic program. I've used every program out there through VR. Fuser is the actual truth. There's nothing it can't do. And so in Fuser, you can host what's called a collaborative session. So I open my model and I host, and then you come into my session, you come into my session, and then all three of us are now standing in the model. We're talking to each other, and we're walking around, moving, doing things like that. So it's hosted through the actual software.
And does HTC have an application for it? How does it go? How does that connect?
HTC, no, Fuser just knows that it can run, so Fuser can run a Rift, it can run a Vive, it can run anything. There's no direct link to, it's a standalone program that just knows how to work with all the hardware.
Cool.
Yeah, it's very simple to use, very simple. I recommend you guys take a look at Fuser, it's a great program. Sure.
Have you noticed a measurable change in the number of edits you get from customers in VR versus when you used to show them to 3D from?
Yeah, a little bit, because it's still new, so it's hard. I don't have so much data coming back to me yet, but I've noticed that clients are, there's less talk about problems that need to be solved once they're in VR, because you can definitively have an answer. So if one person says, well, I think it's this, the other person says, well, I think it's this, so you go into VR, you don't have to think anymore. You have the answer. So I've seen it solve problems much quicker. I've seen it end arguments and minimize meetings. And I don't have enough data to accurately tell you that I've had this many people come back to me and tell me this yet, because it's still very new, and introducing it to our clients is still very new. And they're sort of stepping into it lightly. But I personally feel like they're going to be amazed with how much they're going to. I mean, me personally, what the change I've seen in my own workflow is amazing. So I'm sure I'll find out over the next couple months, get some feedback. Sorry.
So I assume that sometimes the client's not always coming to you.
Yes.
Sometimes you're going to them.
Absolutely.
Okay. So what's your preferred platform to display your design to the clients? And when you make updates on your end, let's say they all can't be made on the fly.
Right.
Of course, they make a decision a month later.
Right.
So instead of you flying back out to the client, is there a way now that you've found to push out this update to the client where they can view your update, maybe not where they have their own VR headset
Right.
sitting in their conference room, but via mobile platform or something like that, where they still kind of get an idea of this?
Absolutely. VR, Fuser has a mobile platform. So we can actually, I can save mobile versions, and then people can, to a cloud. You can access it from the cloud, download it right to your phone. And so you can be actually walking through the model on your phone. It's not going to look as beautiful, because we need to put the mode down a little bit so it doesn't crash your phone. But you can actually hit a button and put the phone into cardboard and put that thing on your face and walk through the building as well. So mobile, you can do that, and we can do that also, obviously, through desktop. Sorry.
Are you, when you go mobile, are you actually giving them a mobile app that they can like navigate around, or are you outputting like a stereoscopic 360?
I am giving, we use currently with our stereoscopic 3D panels, we use the Iris VR scope account. Iris is one of our trusted partners. We've been partnered with Shane and that whole group since they started. Along with Fuser, we're partners with them as well. And not because we really get a benefit from them, it's because they're the best. So I talk about Fuser not because Fuser's going to give me anything for it, but it's the best software, guys. I'm trying to save you some time. And don't do the end around trying to save money. Just go to the best, because this stuff really does it. But really, Fuser is a platform I use, and it's easy to get updates to people, mobilely or through the web. You don't have to always be in the same spot, because that would be obsolete, right? Sir?
Do you find, I don't know if you do the final photo-ready version with every client, but do you find that there's a lot of demand for that after the initial kind of work?
I find the demand for photoreal coming, in the beginning they want photoreal because they're web, and it's cool. And it's almost like they want to show it to everybody, right? Because people that have their own projects, they take ownership of their projects, their own work, and they're proud of it. But when they realize that you can't do any work in photoreal, they leave that to a marketing effort. So what they do is they put the photoreal in their marketing budget, and they put the Fuser work in their construction budget. So they're still getting work done in Fuser, and the photoreal is really, at the end of the day, we know the fabric, we know the texture, we know the materials. So let's put all that together. Once they realize that once we put that together, we can't change it, then they begin to sort of think about it a little more when they're going to need it. Because it is expensive, that model gets expensive, depending on how big it is.
They still end up tending to want it.
They still tend to want it. It's because it's such an accurate representation of their future project that they get really excited and they want to access it now. So they want to be in it now. So it's really the excitement is from, honestly, it's from the graphics, because they look so great. They want to jump in, and it's really that cool factor, right? So that's why my job is to help explain to people, yes, it's cool, but let's get work done too. We have to get work done. It can't just be video games. There's got to be some work too, right?
Probably won't be long.
It won't be long.
Or it's both.
Yeah, it's going to be both, which I'm happy for. Matt.
I'm interested to learn what you have seen in terms of human factors and the human-computer interaction. What are the biggest challenges or limitations there? So, you know, in terms of, do people feel disoriented when they take the headset
That's a
off?
great question.
Do they feel motion sickness?
That is a great question.
When I first put the Oculus on my mom, she said, "You're trying to make me fall." So it's just kind of interesting. You know, you talked about you being trained to use the space. Well, we're kind of trained to use these, and we think everyone has seen them already and used them. So I'm interested, because you've had so much contact with the general public, just to learn what you see as the challenges or limitations from that side of things.
Definitely VR sickness is a real thing.
Mm-hmm.
So VR sickness, if you guys aren't aware, it's when your brain knows that you're physically not moving, but your brain also sees that you're moving through space in the headset. It can make you dizzy. Also, vertigo is a big thing. Anyone that has vertigo, before I do demos, I always ask if the person has vertigo, because VR can set your vertigo off for a couple days, and that's not fun. Dizzy. Another trick I do is, the answer to your question is these physical effects.
Mm-hmm.
The dizziness. You've all seen those videos on the internet where the guy's in VR and falls over because he's trying to reach for something that's not there. And that's real stuff. I usually put a chair in the middle of the room, so the person, either in VR, they're holding on to something.
Okay.
So they know that there's something at least around them physical, because most of the people I put in VR, they reach for something anyway. They're reaching for that, you know, the balcony rail or something. So I put something there in reality for them to hold on to and how steady they're, but it's really all about your head. And it's less about the physical problem you're gonna have and more about how your head is computing what your eyes see and what your body is or is not doing. So sitting VR is probably safest for people that aren't that used to it. And then, then I have people that I go and they're like, let's go to the top of the building and jump just for fun, you know? And we do. And they're fine with that. Because they can do it, but sometimes the physicality is a bit rough on the human body. Yeah. Sorry.
Have you done anything with brownfields where you're actually going out to a physical space and then showing using like an augmented reality or mixed reality technology, the new buildings actually where they're going to be built?
What I do is something similar to that. We don't use AR as much right now. AR is going to be evident in our industry, but not for another couple of years. We use the 3D stereoscopic panels that are in like the Gear VR. So you're standing there, because I can render the spot in the model anywhere I want. So I can go out to the site and I can understand that this spot in the site is this same spot in the model. I'm going to render that spot in the model. And then what I do is I go out to the site, and then you can put those up to your head. And be like, okay, there's no building. Hey, there's a building, and this is what's going to be in the future. Okay, no building. There's a building. So we do this for example, retailers. Retailers want to understand what their view is outside of their window. What does it look like when they get to the front door of their retail spot? So I get a spot, I shoot that panel, and then you go to the site and you can put little logos on the ground where all the panels are shot. And they can stand there, put up to the say, okay, this is what it's going to look like from the front of my retail in a project that's going to be built 2 years from now. AR would probably be a little more useful for that. It's just not fully developed enough for us right now. Because AR requires a little bit of reality, right? And not necessarily, but it does work off it. That's why it's augmented reality. With VR, it's easier because I'm talking about or designing something that literally doesn't exist. So unless it's an addition to something that does exist, I'm better off with VR because I need a whole new world.